Let's try writing another function rule from a table. Let's look, in fact, at question number 12 in this homework assignment. It gives us a table that looks something like this. We have f(x) and f of x. We have the values 0, 1, 2, 3, and 2, 5, 17. We need to finish filling out the table and then write the function rule that the table is modeling. So, looking for patterns is our first step. The x values, remember, those can be addition. So we have from 0 to 1, we're just adding 1. 1 to 2, adding 1, 2 to 3, adding 1. So we just keep adding 1 and we can finish filling that in with 4 and 5. The f of x1 is going to be a little bit more difficult this time. We have to look for a pattern using multiplication. So, 2 times what equals 5? Well, an easy way to kind of approach this is to go in reverse and say 5 divided by 2 is what? Well, that's 2.5, right? So let's see if multiplying by 2.5 would get us to 17. So in our calculators, all we have to do is say 5 times 2.5 equals, no, doesn't give it to us, right? Doesn't help, it's not the same pattern. So let's see if, rather than finding the pattern first, we could write the rule and then go back and fill in the rest of the table. Now, we know that when we're writing an exponential function rule, we only need two x values. We need when x is 0 and when x is 1. And if you notice, we have both of those right here. Okay? So, let's go ahead and just start in and see if we can write the rule first. So we have y equals b to the x plus c. And the very first step, I'm using when x is 0, right? So I'm going to use the point when x is 0, y is 2. So the y value is 2, the x value is 0, and we know that anything to the 0 power is 1, so we have 2 equals 1 plus c. Want to get c by itself, so we'll subtract 1 from both sides. 2 minus 1 is 1. So in this case, our c value is 1, which tells us we'll have a vertical shift of up 1 unit. So let's go to our next step. We use that same y equals b to the x plus c, but we use our second point that we have when x is 1, y is 5. So the y value is 5, the x value is 1, and remember our c value in this case is also 1. So we'll go ahead and plug that in. So we have 5 equals b to the 1, which is just b, plus 1. Subtract 1 from both sides, and we learn that 4 is our b value. So our very last step, all we have to do is plug in b and c. So in y equals b to the x plus c, the b value is 4, and the c value is positive 1. So we have y equals b to the x plus 1. So there is the function rule. So now we can use this rule to finish filling in the table. Put this over here. Okay. So to finish filling in the table, all we need to do is plug our domain values in to get our range values, right? So I'm going to use our rule. Oops. Sorry. Going to use our rule 3 times, right? To find when x is 3, x is 4, and x is 5. So let's go ahead and write that rule out. Y equals 4 to the x plus 1. Y equals 4 to, oops. 4 to the x plus 1. And y equals 4 to the x plus 1. So our first x value is 3, our second one is 4, and our third is 5. 4 to the third power, 4 times 4 is 16, 16 times 4 is 64. Bring down the plus 1, 64 plus 1 is 65. So when x is 3, y is 65. Next we have 4 to the fourth power. Get my calculator out. So 4 raised to the fourth power is 256. Bring down the plus 1. So we have 257 as the y value when x is 4. And our last one, we have 4 to the fifth power, which is 1024 plus 1, which is 1025. So when x is 5, y is 1025. So that was a little bit of a tricky pattern to kind of work out on our own, but it's easy to find the y values once we have the rule. So easier problems, you'll probably be able to figure out the pattern first and then write the rule from there. The more difficult problems, I think it's easier to just go ahead and write the rule first and work our way backwards.